Good afternoon, grade 9. How are you doing? I hope you are fine and staying safe at home. We're going to continue our revision. We're revising and making a cumulative revision. We stopped yesterday. We did the question 3. We stopped at question 4, so we're going to answer question 4. Find the least common multiple for each pair. As we said, to do the least common multiple, I have to find the LCM, factor each polynomial completely, then list the different factors. So I have to factor. 4x is already factored. 3x squared will be 3xx. So I will take the greatest power, which is x squared. So I will write here 4 multiplied 3 will be 12. When I factor it, it will be 4x. Let me write it here. This one will be 4x, and the other one will be 3xx. Then I'm going to take 3 and 4 together, so it will be here. I'm going to write it 12 and take the highest exponent, which is x squared. Okay, here, if I have a common term, I'm going to take one of them. So I'm going to take x plus 2. And x plus okay, girls. Number 5, we have described the transformation. G of x is equal 1 over x minus 2. If we go back to the rational functions, I have the original rule is a over x minus h plus k. So it is a over x minus h. X minus h. So the original rule has the negative sign. So the value of h is always have the inverse of the sign. So h here is the inverse of negative 2, which is positive 2. So h is 2. Since h is 2 here, I'm going to write here h is equal to 2. Since h is equal to 2, so it is horizontal translation 2 units to the right, because 2h here is positive and it is horizontal translation, and when h is positive, so it is translated horizontally to the right. When h is positive, so it will be translated horizontally to the right. So I will say horizontal okay. I have here 1 over x plus 3. So all the function plus 3. When all the function is added to 3, so it is vertical translation. So what is the value of k here? Value of k here, according to the rule, I have a over x minus h plus k. So k, it will take the value of what is written in the problem, the same sign, because in the original rule it has positive. So in any problem it will take the sign of what is written. So it is positive 3, so k is equal to 3. So it is vertical. When k is positive, so it will be up. So vertical translation 3 units Okay. Answer each about the function f of x 1 over x plus 3 minus 7. Okay. Describe the transformation from the parent function. Okay. 1 over x plus 3 minus 7. What happened here? Two transformation happened here. First, I have plus 1 over x plus 3. So h here takes the sign inverse of the sign here. So h is negative 3. H is equal to negative 3. And k is equal to negative 7. K takes the same sign of the problem here, and h take inverse of the sign. So here, what happened here? Horizontal translation and vertical translation. So since h here is negative, so horizontal translation 3 units to the left, then vertical translation 7 units down, because when k is negative, so it will translate it down. So what I'm going to write here, I'm going to write horizontal translation 3 units to the left, because h has negative sign, then vertical translation 7 units down. Okay, girls, sorry, the mic was unmuted. So I will repeat what I have said. Find the asymptote of this function b. To find the asymptote for this function, I have to get, wait, here I have a problem here. Yes. When it is required to get the asymptote, I have to get x and y. x here to get the value of x that makes the denominator is equal to 0. To get the denominator, to get the value of x that makes the denominator is equal to 0. So x plus 3 is equal to 0, so I take the denominator and I wrote it's equal to 0. So x plus 3 is equal to 0, so x is equal to negative 3. So the value of x that makes the denominator is equal to 0, it is equal to negative 3. So this is the first asymptote that I will write. What is the second asymptote? The second asymptote is y. What is the value of y here? The value of y here is negative 7. The value of y here is negative 7. So when it is required to get the asymptote, I will get x and y. X is the value of x that makes the denominator is equal to 0, and y is here that it is equal to negative 7. So I will write here the asymptote here. X is equal to negative 3, and y is equal to negative 7. Now I want to get the domain. The domain is for x values. The domain is for x values. How I will write the domain? The domain is for x values. D is equal to, what x value is here? X value is here is negative 3, that makes the denominator is equal to 0. So how I would write it? I would write it like this form. Should be a line. I will try to insert a line here. Where x is not equal to negative 3 and close. Okay. This is how I write the domain. Exactly, I will take this one, copy, and I will write it for the range. The range is for the y value. The range is for the y value. What is the y value here? I will replace it and write here y. Okay. This is how I write the domain and the range. Domain is for the x values and the range is for the y values. And this is how I write exactly the form of the domain and the form of the range. Again, the domain is for the x values and the range is for the y values.